So hello students, I welcome you all on this YouTube channel. This question has been asked in ESC 2011 examination. So please read the question statement. Find the Thevenin's equivalent voltage VTH and Thevenin's equivalent resistance RTH to the left of terminals A and B in the given figure, right? So did you understand the question? So in this question you have to calculate the Thevenin's equivalent voltage VTH and Thevenin's equivalent resistance RTH across terminals A and B, right? He is saying find out VTH and RTH to the left of terminals A and B. That means across to the left of terminals A and B you have to find out. Across the terminal AB you have to find out the Thevenin's equivalent circuit. That means VTH and RTH you have to find out, right? So I have already discussed the method to find out Thevenin's equivalent circuit. You can go to the playlist under the electrical technology. You can find out all the steps. So the same steps we are going to follow here in this question to find out the Thevenin's equivalent circuit, that means VTH and RTH, right? So first step is, step number 1 is to calculate Thevenin's voltage VTH, right? So this is the step number 1 to calculate VTH. So VTH is nothing but, I told you that it is the open circuit voltage across those terminals where you want to find out the Thevenin's equivalent circuit. So such terminals are A and B, right? It is already open circuit, right? So since it is already open circuit, so you can no need to remove anything across these two terminals, right? So suppose any resistance or any impedance is connected across these two terminals, then first you have to remove this, right, in order to make it open circuit, right? So it is already removed here, so that means you need not to remove anything across terminals A and B, and now you have to find out Thevenin's voltage VTH across these two terminals, right? So the Thevenin's equivalent voltage is nothing but the open circuit voltage across those terminals where you want to find out the Thevenin's equivalent circuit, right? So VTH is nothing but VOC. VOC is open circuit voltage, right? So this is nothing but open circuit voltage across terminals A and B, right? So how to find out VTH? So just see here in this question, just see here, have a look at it. 12 volt voltage source has been connected here, and in series with this 6 ohm resistance is connected, right? This is the current source of 6 amperes, right? Now this 12 volt voltage source and this 6 ampere current source both are independent sources, right? Because 12 volt is not depending on any other parameter. This is independent. It is having a fixed value of 12 volt, right? Similarly 6 ampere, it is having fixed value. That means it is a independent current source. 12 volt, again it is a independent voltage source, right? So both are independent sources, right? So this is a 6 ohm resistance and this is a 4 ohm resistance, right? So how to solve this? How to calculate VTH across these two terminals? You can write that with respect to ground, what is the potential of this this terminal? See, this is the ground terminal, right? This is the ground, 0 volt. This is the ground terminal, right? That means it is 0 volt here. This is 0 volt, right? So with respect to this 0 volt, so this is 0 volt, right? So this point and this point both are the same point, so this is also 0 volt, right? Again this point and this point both are the same point because both are joined by same wire. So this point, this point, this point and this point also all are at same potential. And what is the potential of all these points? This is at ground potential, right? 0 volt, right? So now with respect to 0 volt, what is the potential of this volt? It is VTH volts higher, right? So this I can write this this is the potential of this node is VTH, right? Potential of this node is VTH. Now if this is a ground volt, this is a ground potential 0 volt, then what is the potential of this node? This is definitely 12 volt higher. With respect to this point, with respect to this node, potential of this node is 12 volt higher. It is indicated by this plus sign, right? Plus indicate that this is higher, right? So here you will write plus 12 volt, right? Plus 12, right? So this potential of this node is 12 volt, right? Now, so my aim is to apply Kirchhoff's current law. You can either apply KVL or KCL, whichever is simpler, you have to choose that, right? So I'm choosing Kirchhoff's current law, right? So now potential of this node, can you tell me what is potential of this node? You cannot tell me what is potential, right? You cannot tell me because you do not know what is voltage drop across this current source, right? Right now you do not know. So right now I am assuming that potential of this node is nothing but V naught. Let me assume, right? I will calculate this. I will calculate this V naught, right? Now I will apply Kirchhoff's current law at the node, right? Kirchhoff's current law at the node, right? So how to apply? So have a look at it. So I am going to apply Kirchhoff's current law at this node, right? At this node I am going to apply. So suppose the direction of currents at this node are like this. Suppose this is the current in this branch, it is flowing like this towards the node, right? 6 ampere current is flowing from bottom to top, right? Upward it is flowing. So 6 ampere current is upward like this, right? And suppose the direction of current in this resistance, which is equal to 6 ohm, is suppose like this, right? So now I am going to apply Kirchhoff's current law at this node, right? So Kirchhoff's current law says that algebraic sum of all the incoming current at a particular node, right, is equal to algebraic sum of all the currents leaving the same node, right? What is Kirchhoff's current law? It says that sum of all the incoming current at a node, algebraic sum of all the current incoming at the node is equal to algebraic sum of all the outgoing current to that node, right? Outgoing current from that node, right? So can you tell me what is this current? See, if you want to find out this current, then first of all you should know potential of this node and this node and the resistance between these two nodes, right? So I told you that this is 12 volt, right? This is V naught and the resistance in between these two nodes is 6 ohm, right? So then you will write, I am going to write Kirchhoff's current law at this node, right? So at this node, when you write, you will first have to write 12, right? 12 minus V naught. See, I am assuming that the direction of current is like this. That means this potential I am assuming to be higher, right? That's why the current is flowing like this, because current always flows from high potential to low potential, right? If you do opposite of it, then the sign will be reversed, definitely, right? So this current, if you want to write out, then you will write 12 minus V naught, 12 minus V naught divided by this resistance, which is equal to how much? It is equal to 6 ohm, right? So this is the current which is flowing in this 6 ohm resistance, right? Now what is the value of this current? This is 6 ohm, so write 6 ohm here. So this is 6 ohm, this is 6 ohm, right? So sorry, 6 ampere, not ohm, 6 ampere. So this 6 ampere plus this current is equal to this current, and what is the value of this current? V naught minus VTH by 6, right? So V naught minus VTH divided by 6. So this is the current which is flowing in this 6 ohm resistance, right? So now you can solve this equation. So when you solve this equation, you will get 2 V naught equal to 48 plus VTH. So 12 minus V naught plus 6 into 6 divided by 6, and here you will get V naught minus VTH divided by 6, right? So when you solve this further, you will get 2 V naught equal to 2 V naught equal to 2 V naught equal to 48 plus VTH. So this is suppose equation number 1, right? 2 V naught equal to 48 plus VTH, right? So now by any means, if I am able to find out this V naught, voltage V naught, then I can find out, definitely find out VTH, Thevenin's voltage VTH, right? So how to find out this voltage V naught? How to find out voltage V naught? For V naught, you can apply Kirchhoff's current law again on this node, right? So suppose the current is flowing like this, at this, from this node. This current is the incoming current, this is outgoing current, right? So have a look at it. So I'm going to apply Kirchhoff's current law at this node, right? So algebraic sum of all the incoming current is equal to algebraic sum of all the outgoing currents. So this is incoming, this is outgoing, this is incoming, this is outgoing, right? So that means what is this current? V naught minus VTH by 6. So write V naught minus VTH by 6, and this is equal to VTH minus 0 by 4. So VTH minus 0 divided by 4, right? So from here you will get 4 V naught is equal to 10 VTH. So this will give you, this equation will give you 4 V naught is equal to 10 VTH. 4 V naught is equal to, just solve this, 4 V naught is equal to 10 VTH, or V naught is equal to 2.5 VTH, right? So this is suppose equation number 2. Now you get 2 equation and 2 unknown. You can now easily find out V naught and VTH, both the voltages, right? So just put this value of V naught, which is equal to 2.5 VTH, in this equation number 1. Put this V naught in this equation number 1. So 2 V naught is 2.5 VTH, so 2 V naught becomes 5 VTH. So from the equation number 1, you will write 5 VTH is equal to now 48. This is equal to 48 plus VTH, right? So 5 VTH minus VTH, 4 VTH equal to 48. for VTH equal to 48, it implies that VTH is equal to 12 volt, right? VTH equal to 12 volts. Now, step number 1 is completed. Now, second step is calculation of RTH, Thevenin's equivalent resistance. Thevenin's equivalent resistance RTH. So I told you that if you want to calculate Thevenin's equivalent resistance RTH, then for that, first of all, what you have to do? You will first deactivate all the independent sources, right? So what is the meaning of deactivating all the independent sources? Meaning is that if it is independent voltage source, then to deactivate it, that means to kill it, to nullify the effect of this voltage source, you have to make it short if it is an independent voltage source, right? For independent voltage source, you make it short circuit, and for independent current source, you will make it open circuit. That's the meaning, right? So here, when you make it short circuit, see, when you make it short circuit, then the circuit will be something like this. I am shorting this, right? See here, I am shorting this. So when I short this, effect will be nullified, right? That means this potential is 0 now, this is also 0 volt, right? Because both points are shorted. This is independent current source, then you have to make it open circuit, right? To nullify the effect of 6 ampere current source, right? So this is now open circuit, so effect is nullified due to this independent current source, right? Now find out RTH across these two terminals, that means across A and B. So RTH, when you want to find out, then you will have to look like this. You should stand here like this and look the terminal towards the left, right? Because he is saying you want to find out Thevenin's equivalent VTH and RTH to the left of the terminal. So that means you should look left, to the left side, right? So now calculate equivalent resistance, right? RTH is nothing but the equivalent resistance across those terminals where you want to find out the Thevenin's equivalent resistance RTH, right? So have a look at it. This resistance and this resistance, definitely they are in series, right? They are in series. So when they are in series, that means you have to add 6 plus 6, and this total combination of 6 plus 6 is parallel with this 4 ohm, right? So what is RTH now? RTH is nothing but 6 plus 6 in parallel with 4 ohm. So into 4 divided by 6 plus 6 plus 4, right? So like this you can calculate RTH. So RTH is equal to this value, and when you solve this, it will come out to be equal to 3 ohm, right? 3 ohms. So which option is correct? Which option is correct now? Option B is correct, right? 12 volt and 3 ohm. Option B is correct, that means 12 volt and 3 ohm. 12 volt is the Thevenin's equivalent voltage and 3 ohm is the Thevenin's equivalent resistance. So option B is correct. 12 volt is the Thevenin's equivalent voltage and 3 ohm is the Thevenin's equivalent resistance across the terminals A and B, right? Now suppose the terminals A and B are something different, then these two values will change, right? Suppose he is asking you to calculate Thevenin's equivalent circuit across these two terminals, across 6 ohm, then terminals will be changed now, and accordingly whole calculation will change, right? So you should always find out the Thevenin's equivalent circuit across those terminals where you are asked to do so, right? So here B is correct, right? RTH is 3 ohm, VTH is 12 volt. VTH is 12 volt. So if he asks you to draw the Thevenin's equivalent circuit in the step number 3, see calculation of RTH is a step number 2, right? This is a step number 2. Calculation of VTH is step number 1. Now step number 3 is to draw the Thevenin's equivalent circuit. So in order to draw the Thevenin's equivalent circuit, I think this is visible to you. Here I am going to draw Thevenin's equivalent circuit. If you want to draw, then it is the series combination of VTH, right? Thevenin's voltage VTH in series with Thevenin's equivalent resistance RTH, right? So this is the Thevenin's equivalent circuit across terminal A and B, right? So this is the Thevenin's equivalent circuit, VTH and RTH. VTH is equal to 12 volt and RTH is equal to 3 ohms, right? So this is the Thevenin's equivalent circuit. Step number 3. So likewise in these steps you can find out the Thevenin's equivalent circuit across the terminals A and B, right? So this is the terminal B, this is A and this is B. And Thevenin's equivalent circuit is nothing but it is the VTH, Thevenin's voltage VTH in series with Thevenin's equivalent resistance RTH. VTH in series with RTH, Thevenin's voltage in series with Thevenin's equivalent resistance RTH is the Thevenin's equivalent circuit, right? So RTH, remember, is calculated under the condition when all the independent sources are deactivated, right? If any dependent source is present, then you cannot deactivate this, right? You must remember, if any dependent source is present, then you cannot deactivate it. That means if it is a dependent voltage source, then you cannot make it short circuit. And if it is dependent current source, then you cannot make it open circuit. So all the dependent sources cannot be deactivated. You can only deactivate the independent sources, right? For dependent sources, calculation of RTH would be different, right? So you must deactivate the independent sources for calculation of RTH. Thevenin's equivalent resistance RTH, right? So thank you very much. If you like, then you can subscribe the channel for all such kind of questions on GATE and ES. So thank you very much. Thanks for watching.